This third video is actually solving the homework assignment number 3 for the kinematics module. So I wanted to give you guys a video of me actually solving this thing outright. We throw an object up in the air with an initial velocity of 50 meters per second. The acceleration is negative 10 meters per second squared because gravity is going to affect this object. We throw it up in the air. Gravity is always negative 10 meters per second squared as the object is in the air. The final velocity when we get up to maximum height is 0 meters per second. I'm going to use this information to get the time that it takes to get to the maximum height. So I'm going to do v is equal to v naught plus at. Final velocity is 0, initial velocity is 50, the acceleration is negative 10, you have to include the minus sign right there, and we're trying to find the time. Move the 50 to the other side, that becomes negative 50 divided by negative 10, we get a time of 5 seconds, okay? In order to find how high the object got, I'm going to use the delta x equation, v naught t plus 1/2 at squared. Now you got to be careful on this equation. The initial velocity is 50, that's positive. The acceleration over here is negative 10, so you have to include that minus sign. So delta x is equal to, replace the initial velocity with 50. The time is 5 seconds. The acceleration is negative 10. The time is 5, and we're going to square it. 50 times 5 is 250. Negative 10, 5 squared is going to be 25. 25 multiplied by negative 10 is negative 250. Half of negative 250 is minus 125. Please be careful with your minus sign. And that gives us a delta x of 125 meters. So the maximum height that we're going to reach is 125 meters, and the time is going to be 5 seconds. That's the easy part of the problem. That's the easy part of the problem. The graphs are the hard part, which is why I'm making this video. We're going to start with the acceleration versus time graph. If you remember from lecture, the acceleration graph is always going to be the easiest in this class. Every second, the acceleration is negative 10 meters per second squared. So the acceleration is a horizontal line of negative 10 meters per second squared every second. Every second we have an acceleration of negative 10 meters per second squared. That's good, okay? Now, the velocity graph, remember, we need to start where the initial velocity is. So our initial velocity is not 0. Our initial velocity is 50 meters per second. So we're starting right here at 50 meters per second. Since we have a negative acceleration, we know that this has to be a linear downward trajectory. So linear downward trajectory. Notice that we're crossing the axis right here. This is going to be 0 velocity. Everybody should know what that time is. That time is 5 seconds. It took 5 seconds to get to 0 velocity. So on my graph, we should cross the x-axis at 5 seconds. Okay? Now the position graph is really, really hard. Okay? And I did this to you guys on purpose. We're going to start at the origin. We're going to start at the origin. The problem here is we have a starting velocity that's positive. The acceleration is negative. So this object is going to slow down as it goes up. It's going to slow down. Then it's going to speed up as it falls back down to the ground. Now, in class, we said that if you have a negative acceleration, you're going to have a downward curve. So you might think that this is going to be the downward curve right here. It's a little bit more complicated than that. The graph actually looks like this. The graph looks like this. So it is an upside down parabola. It is an upside down parabola. This portion of the graph should look familiar to you. That's the downward curve. However, because the velocity started out positive, there is a period of time where we are going to slow down. So we have to draw the complete upside down parabola in order to show the nature of this object. Slowing down as it goes up and then speeding up as it comes down. So this is the full parabola. You only saw the right-hand part of the parabola when we started with a velocity that was 0, but since this velocity starts off positive, we need to see the full parabola. And this maximum height that we reach should be 125 meters. So it is still a downward curve. It is still a downward curve. However, we need to draw the full parabola of this object as we slow down, get to 0 velocity right here, and this would also be 5 seconds, and then the object will fall to ground. Now, the good news is I'm not going to give you a problem this hard on the test. I promise. I'm only going to ask you 2 graphic questions, and they're going to be much more like what we did in class. Okay, that's why I'm making this video right now, because I'm sure you guys are a little panicked. This is a much more complicated problem because the velocity started out positive. I will not ask you something like this on the test. Okay? Hopefully this helps you guys out a little bit when it comes to graphs, and it also shows you just how complicated the graphs can be.